Hey folks, we're going to have more quadratics today. And I'm just going to be right up front and honest that my approach on section 3 might not be what the author wants you to do. The author probably wants you to just graph this quadratic right here using the skills that we learned in section 1. So if you feel more comfortable doing it that way, rather than using Desmos, I totally understand that. Look, we know that negative. I'm thinking one thing and then writing something else here. So, like, we know that negative x squared means that the a value is -1, right? And we know the plus 4x means that the b value equals 4. So we know that the vertex has to be on the line x equals, this is the line of symmetry, opposite of b all over 2 times a, which gives us -4 divided by -2, which gives us 2. So when I go over to Desmos and I look, it's almost like I'm kind of cheating here, right? I mean, I am not using any skill, but we're trying to kind of honestly blast through chapter 12, but still get some of the concepts that we need to have for future use. Okay, so it's often used in higher level math. Technology is often used, and so what I want you to understand about this is that you have some skills now to make sure that you're looking at the right graph, right? Like, do I know my graph is going down? Is it a downward opening parabola? Yeah, because the negative in front of x squared means it's downward opening. If I do the opposite of b over 2a, does that tell me that my vertex is at 2? Yeah, okay, so that's making sense, right? Is my y-intercept 5? So I'm hoping that, you have some of these skills, which, I hope it's not like completely uncomfortable for you to listen to that discussion, is what I'm trying to say, right? And so what we're going to do in our homework, though, is we're just going to use Desmos. We're going to say, okay, the vertex is over here at 2, and we have that parabola going down like this, okay? And what they want us to figure out is, when is the parabola equal to 0? In other words, when is the y value equal to 0? So let's switch over here. And like when I click on here, see, it's saying the x value is 0.3 and the y value is 6.11. The x value is -0.42, the y value is 3.144. So really what I'm looking for is this spot right here. The y value is 0 when x is -1. And the y value is 5 or 0 when x is equal to 5, right? If x is 5, then the y is 0. So we're solving this question about, when is this function equal to 0? What do I have to put in for x to make the left side of the equation equal to 0? That's what solving means. We're going to find out what I have to put in for x to make the function equal to 0. And we're going to answer it using Desmos. So we saw on our graph that it was at, I think it was at -1, wasn't it? And then it was over here. Let's look back over there again. It was at 5, right? So over here at 5. So our two answers are -1 and 5. So that's right. We have two answers on this one. Okay, so let's look at some different situations. What I mean by that is, are they all going to have two answers? Okay, so if I had a parabola that was going to go up, I'd get rid of the negative, right? If I want that parabola to go up instead of down. So I delete the negative. Now let's say we want to know when that's equal to 0. Okay, so let's put that in our notes. Example 2 is going to be x squared. Example 2 equals, I don't like that either. I have that little dot over there. Give me a second here. Example 2 is x squared plus 4x plus 5 equals 0. Now our parabola looked like this, didn't it? Did something like this. We still have 5 for a y-intercept, but we're never going to hit the x-axis. So this would be a situation where we have no solutions. Okay, there are no solutions to our graph. Is it possible, okay, let's just say this before I ask the question. We had two situations, two answers, two places where the graph hit the x-axis. Here we have no solutions because the graph didn't hit the x-axis. Is it possible to have one solution? Okay, so what I'm asking is, do you think it's possible to have a parabola that would just touch the x-axis in one spot? Well, sure. let's try to make that happen. So if I come over here and let's say I reduce my 5 down to a 4. Hey, look at that. So if the equation was x squared plus 4x plus 4, now I only have one place where it hits the x-axis, okay? So you could have one solution. Add that to your notes right now. One solution. Now they do call these things down here a double root. All right. Or the book, let me see. The book says that our book uses the words yeah, they use the same word that I use in pre-calculus. It's a double root. So you might see that in your choices when you're doing the McGraw-Hill assignment today. So this one's called a double root. Okay, so let's just kind of summarize what we were doing. We have a quadratic. We're going to try to solve that quadratic. We want to know when it's equal to some number. Now, is it always going to be equal to 0? Is our quadratic always going to be equal to 0? Well, let's say it was like a 5 over here. Well, I would subtract 5 from both sides, so my c value becomes something different. But yes, we always want it to be equal to 0 because it allows us to solve the problem really easily. We can find the x-intercepts. We can also use some other techniques that we're going to learn later in later sections. If it's equal to 0, it's really, really helpful. I should say it doesn't have to be equal to 0 for graphing, but that's kind of down the road, and we don't have to worry about that right now. But all of your problems today are you're going to want to get it equal to 0, and then you're going to want to graph it, and then you're going to want to find the x-intercept. So looking at one of the problems, let's try one real quick before I sign off here. All right, problem number 5, for example, okay? Problem 5 says x squared, because I don't think I've made this clear, plus 14x, you could skip to problem 5 if you want, is equal to negative 49, okay? There are ways to solve it where it's equal to negative 49. I could probably show that to you right now in under a minute, but we're just going to say, let's move the 49 to the other side. So we're going to put plus 49 on both sides, and we're going to get x squared plus 14x plus 49 all equals 0. We're going to put this into Desmos. So I'm going over to Desmos right now. It was x squared plus 14x plus 49, right? Where does it hit the x-axis? At negative 7. So we've got a double root. We got a double root at negative 7. So x equals negative 7 double root. Okay. Hey, thanks for watching my video. I hope that makes sense. I hope the announcement wasn't too distracting. Hope you can hear me.